will briefly present to you some of our virtualization solutions. Okay, so this is what we're going to discuss today about a little bit of cloud computing. Now, what is cloud computing? Definition and a little bit about development. Well, cloud computing, one of the most widely accepted definitions of cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources. Okay, computing resources means networks, servers, storage, applications, and services. Okay, we can, using cloud computing, you can rapidly access, provision, and release minimal resource management with minimal effort or service provider interaction. So this is the most widely accepted definition of cloud computing. Now, there are three phases of cloud computing in terms of transforming the enterprise IT architecture. Okay, it's cloud computing 1.0, 2.0, and 3.0. Today, we're only going to cover cloud computing 1.0. I'm going to define a little bit what is cloud computing 1.0 and 2.0. 1.0 is, in this phase, deals with virtualization of IT infrastructure resources, okay, which focus on computing virtualization, enterprise IT applications that are completely decoupled from the infrastructure. With virtualization and cluster scheduling software, multiple enterprise IT application instances and runtime environments, guest operating system, for example, can share the same infrastructure. This leads to a high resource utilization and efficiency. Okay, this is what we're going to cover today, and this is what our products that I'm going to introduce to you deal with. Now, in cloud computing 2.0, infrastructure resources are provisioned to cloud tenants and users as standardized services, and management is automated. These are made possible with the introduction of standard services, service provisioning, and resource scheduling automation software on the management plane, and software-defined storage and networking on the data plane. In this phase, the infrastructure resources provisioned to tenants can be VMs or virtual machines, containers, which are also known as lightweight VMs, or even physical machines. This transformation has not yet touched the enterprise applications, middleware, or database software architectures that are above the infrastructure layer. Now, a little bit about virtualization. What is the definition and a bit of overview. Okay, virtualization is a technology that simulates hardware functionalities and creates multiple virtual machines on a physical server. Generally, applications need to run inside an OS, and only one OS can run on a physical server at a time. So if we have, for instance, this is the traditional way. If we have 10 servers, the traditional way, we'll have 10 OSs running on those 10 servers, so one on each server. Virtualization allows VMs that reside on the same physical server to run independent OSs. For instance, we can have Windows and Linux running at the same time. This way, multiple OSs can concurrently run on the same physical server. The essence of virtualization is to separate software from hardware by converting physical devices into logical folders or files. What does this mean? Well, without virtualization, running multiple primary application programs in the same operating system of a physical server may cause runtime conflicts and performance bottlenecks. Running only one application on a dedicated server could solve these problems, but will easily cause low resource utilization. So it means we are wasting a lot of resources. With virtualization, we can run multiple virtual machines that can run on a single physical server, and each virtual machine can run an independent OS. This, of course, improves resource utilization, which is obviously a great thing. Now, we should I will now start to present to you a little bit about our products, mainly those that cover the virtualization. The first one is called Fusion Compute. Fusion Compute. what is Fusion Compute? Well, Fusion Compute is a cloud operating system. This one virtualizes the computing resources, the storage and network resources, implements centralized management and scheduling of the virtual resources through a unified interface. Of course, Fusion Compute provides high system security and reliability and reduces operational costs. You can see in this diagram here the architecture of Fusion Compute. You can consider Fusion Compute as the hypervisor. For instance, the competition of Fusion Compute is, of course, vCenter. Okay, so VMware is our competition. If you know VMware, then Fusion Compute is the same thing, virtualizes the resources. Okay, this is the definition. Of course, here we have more products. For example, you can also see in this diagram we have Fusion Storage, Backup, Ultra VR, Fusion Cube, Fusion Cloud Desktop Solution. We're going to get into those a little bit later, but now we're only going to pay attention to the Fusion Compute part. Okay. How does it help me? What does it do for me? Well, it provides us a unified virtualization platform. Okay, so I have an overview of all our resources, of all our physical resources. Okay, it allocates VM resources on demand. It supports various operating systems, and it isolates the VMs to ensure the quality of service. Okay, another feature that we have is that it can support various hardware platforms. It can support multiple various x86 servers and is compatible with a wide array of storage devices. It supports a big cluster meaning we can have multiple clusters, but one cluster can have up to 128 hosts and can support up to 3,000 virtual machines. It can also support automatic resource scheduling. What does this mean? Well, it means that allows users to define service level agreement policies, fault reporting criteria, and fault rectification policies. It means that it can implement centralized IT resource scheduling. It can manage energy consumption and reduce maintenance costs. It can also allocate dynamically resources based on the load of the servers and services, and thus we can achieve load balancing across servers and service provisioning systems. And this way we can ensure optimal system response and user experience. Okay, on the right side we can see the architecture of Fusion Compute. We have CNA and VRM. These are the two basic components of Fusion Compute. Okay, what do they mean? Well, CNA provides the following functions. It implements the virtual computing function on each host, and it manages the VMs running on that particular host. It also manages the computing, storage, and network resources of each host. Then we have the VRM, which stands for Virtual Resource Manager, and it provides the following functions. It manages the block storage resources in the cluster. It allocates private IP addresses for virtual machines using dynamic host configuration protocol. It manages nodes in the computing cluster and maps physical computing resources to virtual computing resources. It manages the network resources such as IP addresses, virtual area networks, and DHCP service in the cluster, and also allocates IP addresses to the virtual machines. It manages the lifecycle of virtual machines in the cluster and distributes and migrates virtual machines across the host. It can dynamically adjust resources in the cluster. It also implements centralized management of the virtual resources and user data and provides elastic computing, storage, and IP address services. It also allows the O&M engineers to remotely access Fusion Compute through a web interface to perform resource monitoring and management and view resource statistics and reports. So this is what these two components do. Now, we should talk a little bit also in this part on Fusion Compute about virtual machine resource management. What does this mean? Well, it means that virtual machine resource management allows administrators of this platform to create virtual machines using VM templates, or in a custom manner, manage cluster resources. This feature provides the following functions. For instance, automatic resource scheduling, including load balancing mode and dynamic energy saving mode. We can manage VM lifecycle, including creating, deleting, starting, restarting, hibernating, and waking up virtual machines. We can manage storage resources. This one includes managing common disks and shared disks. We can manage the virtual machine security. This one includes custom VLANs. And also we can manage online VM quality of service adjustment. This one includes CPU setting and memory setting. The virtual machine lifecycle management. Well, the virtual machine lifecycle management function allows users and administrators to adjust the VM status based on service load. Users can perform the following operations to a VM. We can create, we can delete, start, stop, restart, hibernate, or query a virtual machine. After receiving a virtual machine creation request, Fusion Compute selects proper physical resources to create the VM based on the specific requirement. The requirements include the VM specifications, such as the number of virtual CPUs, the memory size, and the system disk size, image specifications, and also network specifications. After the VM is created, Fusion Compute monitors the VM running status and its attributes. Users, of course, can stop, restart, and delete VMs as required by our, business requirements, okay? We can hibernate or wake up VMs. We use this function, for example, to hibernate idle VMs. They are not being used anymore when the service load is light, and we can wake them up when the service load is heavy. This improves system resource utilization, so we don't waste any resources at a given time. We can also use Fusion Compute to dynamically adjust virtual machine resources. What does this mean? For example, adjusting the number of virtual CPUs for VMs that are in a running or stop state. Users can add or delete virtual CPUs for virtual machines based on the service load, irrespective of whether the VMs are running or stopped. This allows computing resources to be adjusted in a timely manner based on the requirement. Adjusting the memory size for VMs in the running or stop state. Well, users can increase or decrease the memory size of every VM based on the service load, exactly like they would do with the virtual CPUs. It's irrespective of whether the VMs are running or are in a stop state. This allows memory resources to be adjusted also as with virtual CPUs in a timely manner and can improve resource utilization. We can add or delete virtual NIC cards for every VM, whether it is in a running or stop state. We can attach virtual disks to every virtual machine, whether it's in a running or stop state. So each and every one of these functions can be performed live on every virtual machine. Also, Fusion Compute, this is also a great function. We actually use this function a lot. I will give you an example later on when the challenging cases part will come up. It's about virtual machine live migration. It means Fusion Compute supports virtual machine migration between the hosts that share the same data stores without interrupting services. It means I don't have to stop the VM in order to migrate it from one server to another. This, well, it doesn't reduce service interruption, it completely eliminates service interruption. Okay, so for instance, if we have a faulty server, we can migrate it. We can directly migrate it, and the VM will never stop running. And this This is also good for example for maintenance Windows, and it also is also a very good idea for energy saving in data centers. If we have a light load of VMs that need to run during, I don't know, during the nighttime, we can migrate them to only one host and we can shut down the other host. This will improve, of course, energy saving. Of course, with Fusion Compute, we can have and define the virtual network. We can have virtual NIC cards. We can have virtual DVS. DVS means distributed virtual switch. For example, each host connects to a distributed virtual switch, which functions as a physical switch. The DVS connects to VMs through a virtual port in the downstream direction and to the host NIC card in the upstream direction. The DVS implements network communication between hosts and VMs. Okay, so this is an important part. In addition, the distributed virtual switch ensures unchanged network configuration for VMs when the VMs are migrated across hosts. So this is about a little bit about virtual networking. Now, about virtual storage. We have the storage virtualization. What does it mean? Well, it means that it abstracts resources on a storage device into data stores. Okay, data stores are logical containers that hide the peculiarities of physical storages from virtual machines and provide a unified model for storing VM files. Storage virtualization helps the system better manage virtual infrastructure storage resources with improved resource utilization and increased application uptime. We can use the following storage units as data stores. We can use LUNs. LUN stands for logical unit number on a storage area network on a SAN. We can use that including iSCSI and fiber channel, because you can use iSCSI SAN and or FC SAN. File, we can also use as data stores. We can use file systems or network attached storages. We can use Fusion storage, which we'll talk about a little bit later. We can use local hard disks or local RAM disks. This was about the virtual storage. Of course, we can provide thin or thick storage. I'm not going to go into more in-depth about this one because it might be confusing for you. So let's proceed to Fusion storage because we've spoken about Fusion storage. Okay, what is Fusion storage? Well, Fusion storage block we're going to talk about because this is the most common one. Okay, we have two types. We have Fusion storage block and Fusion storage object. The most common is Fusion storage block. This one provides block storage, distributed storage with extensive scale-up capabilities. By leveraging the storage system software, Fusion storage organizes local storage resources of servers into fully distributed storage pools and provides block storage services for upper-layer applications through SCSI or iSCSI interfaces. Okay, meeting the storage requirements of cloud resource pools and databases. What does this mean? Well, it means that, so as you can see on the right side, we have the block storage service, we have the hardware layer, and it unifies all the storage resources that the servers provide. Let me see. Okay. Yeah, so only 2 slides for Fusion storage. What does Fusion storage apply to? Well, it applies to cloud resource pools. Fusion storage forms large block of storage resource pools by pooling resources of general purpose servers. It enables on-demand resource allocation by integrating with virtual platforms. This one includes Fusion Compute as well, the one that we previously spoke of, and also VMware vSphere, or Microsoft Hyper-V and OpenStack as well, and even our own Huawei Cloud Stack. And it supports a wide range of service applications such as SQL, web, and industry applications. Besides cloud resource pools, it also applies to databases. Fusion storage supports SSD cache and main storage, significantly improving system performance and reliability while retaining high scalability. This provides high performance data access and storage for mission critical enterprise applications. Okay. On this one includes databases, enterprise resource planning, and customer relationship management. Fusion storage. How another benefit of fusion storage would be its great elastic scalability. What does this mean? For instance, we have 10 servers that we've already used for fusion storage. We've created a big pool of storage resources, and scalability means that we can expand upon these resources. We can also easily add more storage nodes according to predefined rules. How can we do that? Well, we can do that, of course, because fusion storage employs a distributed hash table architecture to distribute metadata onto storage nodes, preventing metadata bottlenecks caused by cross-node access. This core architecture allows us for large-scale linear expansion, which is a great thing if we are looking for fast, easy ways to expand our storage resources. It also allows for great reliability. How is that achieved? Well, through cluster management. This cluster management eliminates the system's SPOFs, which is single point of failures. For instance, if we have traditional storage, well, if we have two links, they might fail. Or if you have one link and that fails, that means one single point of failure. With fusion storage, that one is eliminated. Why? Because a faulty node or disk is automatically isolated, preventing adverse impact on system services. We can also have multiple copies. What does this mean? Well, the multi-copy mechanism enables a piece of data to have 2 or 3 copies of itself. The copies are stored in different servers, cabinets, or even equipment rooms. This ensures data integrity and availability, even if a server, cabinet, or equipment room fails. So this is one of the major advantages of fusion storage. Now, in slide number 10, you can see the architecture of fusion storage. We will see here these components, for instance, FSM, FSA, VBS, MDC, ZK, CM, CCDB. Okay, we're gonna go a little bit in depth about what these terms mean and what they mean for fusion storage. Let's start with FSM. FSM means Fusion Storage Manager. This is, of course, this is a VM. What does this process do? Well, the management process of Fusion Storage block storage, this is what FSM does. So this is the management process. We have to deploy FSM on 2 management nodes. They are usually deployed in active and standby mode. FSM automatically starts during management node installation. If one, for instance, FSM1 fails, FSM2 or the standby one will take over. So we'll not have any interruption or service interruption. What does FSA stand for? Well, it stands for Fusion Storage Agent. The management agent process of Fusion Storage is deployed on storage nodes and compute nodes, and it implements communication between the nodes and the Fusion Storage Manager, the one that we previously talked about, the FSM. FSA automatically starts during storage or compute node installation. What does MDC stand for? It stands for Metadata Controller. The Metadata Controller component controls the status of the distributed cluster, as well as data distribution and rebuilding rules. So this one is really important. When we create a control cluster, we use 3, 5, 7, or 9 nodes. when we create them, the metadata controller component automatically starts on these nodes. This one works in conjunction with the zookeeper, ZK. The zookeeper cluster will elect the primary metadata controller to monitor all the other metadata controllers. When the primary MDC fails, the zookeeper cluster elects a new one. Each resource pool has one MDC. When a resource pool is added, the MDC automatically starts. We can have a maximum of 96 metadata controllers that can be started in one system. Now, the zookeeper. The zookeeper is also a component of Fusion Storage. It's actually the distributed coordination service process for applications. It's deployed on each node in the control cluster to form a zookeeper cluster. The zookeeper cluster provides primary arbitration for the metadata controller that we previously spoke about. More than half of the zookeepers must be active and accessible. So meaning if we have 7, we need to have at least 3 up and running in order for Fusion Storage to work properly and not have any service interruption. And the zookeeper automatically starts on the nodes that form the control cluster during the control cluster creation. Now, the next important component is VPS. This process provides distributed storage access point through SCSI or iSCSI interfaces and enables application servers to access the distributed storage resources. The VBS needs to be manually started on servers, and the servers running VBS form a VBS cluster. These are the main components of Fusion Storage. I will speak with you a little bit later about, because we have the challenging cases, and we had one that involves Fusion Storage with zookeeper and the MDC components, and how important are there to the Fusion Storage. And it also will show you the reliability of the system. What happens if, I don't know, one node fails that has these components installed and we have all the other nodes up and running? Means that we will not have any service interruption or any data loss. Now, we will proceed with the Fusion Cube product. What does Fusion Cube mean? Well, I presented to you now Fusion Compute and Fusion Storage. Fusion Cube is a unified manner of deploying these two products together. Okay, we can also independently deploy Fusion Compute or Fusion Storage. We can, for instance, deploy Fusion Compute, then we can deploy Fusion Storage instead of dedicated storage. But Fusion Cube deploys these two products together in a unified manner and also adds a unified or a management portal to both of them. Okay, this one, as you can see in its definition, it's a scalable virtualization infrastructure. We can easily deploy, maintain, and manage different cloud applications. We can deploy, update, customize, and manage service applications. On the right side, we can see the basic architecture of Fusion Cube. Of course, for example, we can use as Fusion Compute, we can use any x86 server. For example, our own servers, we can use Blade servers, we can use rack servers, V3 models, V5 models, you name it. We can use E9000, we can use E6000. And the software, it uses the storage software, which we previously talked about, Fusion Storage. What are some main benefits of Fusion Cube? Well, convergence. We have hardware convergence. Fusion Cube integrates computing, storage, and network resources. We have management convergence. It provides a unified management to increase resource utilization and reduce operating expenses. Simplicity. Fusion Cube implements pre-integration and pre-verification. Automatic device discovery upon power on, unified management, and simplifying service delivery. What does this mean? Simplified installation. Fusion Cube provides a quick installation tool to install the system software in one-click mode. Basically, everything is click, next. Rapid deployment. Supports automatic device discovery and parameter configuration after the system is powered on. This means a rapid service rollout. Easy management provides a unified management interface and automatic fault locating, facilitating routine management. Some of its features include pre-integration. What does this mean? That Fusion Cube has all of its components installed before delivery. We don't have to install them manually. This means simplifying on-site installation and commissioning. The commissioning duration is shortened from several weeks or even months to only hours. Well, this one depends also on previous network configurations. If everything is done and up and running, it will be indeed only a matter of hours. Pre-integration includes hardware pre-installation. Devices are installed in cabinets and cables are connected properly. Software pre-installation. The BIOS and system discrete are configured, and the virtualization software, for example, Fusion Compute, platform management software, Fusion Cube Center, and storage software, Fusion Storage, are pre-installed. Cabinet shipment. The cabinet is assembled and shipped for delivery. Well, this one only applies to E9000 servers. We have also compatibility with mainstream virtualization platforms. This means that Fusion Cube supports the virtualization platforms as Fusion Compute that comes, of course, pre-installed, and also VMware. So it's compatible with VMware as well. We can use, instead of our own Fusion Compute, we can use VMware plus Fusion Storage. So it's fully integrated with VMware as well. We have also another feature that we have is called distributed block storage. Fusion Storage provides distributed storage services for Fusion Cube. Fusion Storage uses a cache algorithm and adaptive data distribution algorithm based on a parallel architecture, which eliminates high data concentration and improves system performance. This means that it allows rapid automatic self-recovery and ensures a high system availability and reliability, as we previously discussed. It also, how more does Fusion Cube help me? Well, it helps me by automatic deployment. Fusion Cube supports automatic deployment. We have a tool that does the deployment. It greatly simplifies operations on site and increases efficiency and quality of deployment. This is achieved because we have pre-installation and pre-integration already, and pre-verification before the delivery and the on-site installation. Devices are automatically discovered after the system is powered on. We have a wizard-based system initialization configuration and allows us to implement the initialization of computing, of storage and network resources, accelerating service rollout. We have this automated deployment tool, which is provided to help users or engineers to rapidly change and upgrade their virtualization platforms. Some typical scenarios that Fusion Cube is used for. Fusion Cube applies to the following typical service scenario. Server virtualization. Integrated Fusion Cube virtualization infrastructures are provided without other application software. Desktop cloud. Virtual desktop infrastructures or virtualization applications run on Fusion Cube. Virtualization infrastructures to provide desktop cloud services. This one is called for instance, our own product is called Fusion Access. We're gonna talk about it a little bit later on. Enterprise Office Automation. Enterprise Office Automation service applications such as Microsoft Exchange and SharePoint run on Fusion Cube virtualization infrastructures. So these are some of the advantages of Fusion Cube. Please note that if we deploy separately Fusion Compute and Fusion Storage, doesn't mean that we have Fusion Cube. The difference between Fusion Cube and the previous two products that I just described is that we have to use Fusion Cube, the Fusion Cube installer, in order to have the license for Fusion Cube. If we install them separately, we're only going to have Fusion Compute and Fusion Storage. But if we want to have, for instance, I'm the customer, okay, and I bought the Fusion Cube product. If I don't deploy it using this installer, I won't have the support after I enter production with the system. So we have to use the Fusion Cube Builder. The Fusion Cube Builder is the automated tool that we have been speaking about, and is a tool used to install and configure Fusion Cube. This one also helps me for future capacity expansions. This manages the installation, automatic discovery of servers, of storage. After we use this tool, we'll have access to the Fusion Cube Center. This one is the central management portal, Fusion Cube. So we have, of course, we have Fusion Compute, we have Fusion Storage. Each and every one of them has their own portals. But Fusion Cube also integrates the Fusion Cube Center, which is the management center of Fusion Cube, and it provides the following functions: the system initialization when the system is powered on for the first time, system resource management, alarm monitoring, performance monitoring, and routine operation and maintenance. It can be used in the following scenarios: automatic hardware discovery and automatic configuration, resource management, system maintenance. I'm not sure if I should know this Fusion Access. This one. These are the components of Fusion Cube. You can see VRM as we have talked before in Fusion Storage, but we can see new terms like MCNA, SNA, CNA, and DBM. What are those? Well, the MCNA is a node that has management function. Fusion Cube Center and Fusion Storage Manager management software is deployed on those nodes. At least 2 MCNA nodes must be deployed. SNA, what does that stand for? An SNA does not support deployment of virtualization platform software. It is a node that adopts the physical deployment mode and has storage function. So it's actually a storage node. We have to have 3 or more, we can have 3 or more SNAs that can be deployed based on service requirement. We have CNAs, a node that provides computing function. We can have 0 CNA nodes, or we can have multiple CNA nodes. It depends on service requirement. But we can also have SCNA, which is a storage. It's a node that provides computing and storage function. We can have 3 or more SCNAs that can be deployed based on service requirements. This is a little bit about Fusion Cube. Now, if everyone agrees, I will proceed further with Fusion Access, which is the last product that we have in virtualization. And what is it? What is Fusion Access? Let's start with the definition. Well, it's a desktop solution. It's a virtual desktop application based on Huawei Fusion Sphere. We can simply call it Fusion Compute. In the Fusion Access desktop solution, hardware and software are deployed on the cloud platform. Users can use thin clients. I'm not sure if you're familiar with that term, but I will explain it to you in just a minute. Or any other device that is connected to the network to access applications and their desktop. This is the logical and architecture of Fusion Access. Okay, we have the hardware resources, a server, storage, network. Then we have the virtualization layer, Fusion Compute. Then we have Fusion Access, which provides the virtual desktop management layer. Now, I told you that I will share with you what the thin client is. Instead of using, I don't know, expensive laptops to work, we can have thin clients. It's like a small box to which we attach a monitor, a keyboard, and a mouse, and we power it on, and we have access to a virtual desktop. Okay, this is what the VMs are used for. We only have access to the VMs. This way we can have access, and please bear in mind that these thin clients are really cheap. So let's say, how much does a laptop cost? I don't know, it can cost from 1,000, 5,000 euros, doesn't really matter. The thin client is 50, perhaps 100 euros, which is really cheap. We can use this one to have access to VMs that can, I don't know, perform as better or even better than a super expensive laptop. But these are thin clients. Now, okay, so this is the architecture. Now, let me tell you a little bit about Fusion Access. In traditional desktop environments, user data is stored on PCs and may be accidentally disclosed or lost due to network attacks. In desktop environments, terminals are decoupled, like we have here in Fusion Access, are decoupled from data which is stored and processed in a data center. In addition, various security measures such as the thin client authentication and encrypted data transmissions are taken to ensure security and reliability of the desktop system. So it helps me with security. It also helps me with efficient maintenance and automatic control. A traditional desktop system suffers a high failure rate. According to statistics, a dedicated engineer is required for management and maintenance of an average of 400 PCs, and the PC maintenance procedure requires 2 to 4 hours. The Fusion Access desktop solution has the following advantages. It improves maintenance efficiency. This solution provides a one-click maintenance tool, which simplifies system maintenance and improves work efficiency. With the desktop cloud, an IT engineer can manage more than 2,000 virtual desktops, which increases the maintenance efficiency by 4 times. It allows automatic resource control. The system monitors the resource usage and implements dynamic resource scheduling to ensure load balancing among the servers. The system also shuts down the idle physical machines to save energy, because of course we need to be green. It can also help us to provision reliable services. In traditional desktop environments, all applications and services are processed on PCs. The system stability is 99.5%, with an annual downtime of 21 hours. In Fusion Access, all applications and services are processed in the data center, which delivers 99.99% service reliability and high performance. The improved reliability helps reduce management and maintenance costs. In traditional desktop environments, users access desktops only using a dedicated device. With Fusion Access, users can access their desktops anytime, anywhere, as long as they have a terminal, like the thin client, that can connect to the network. Because data and desktops are processed in the data centers, users can move from one place to another during work without interrupting the application. It also helps reduce noise and power consumption. Using thin clients reduces the noise in offices from 50 dB to 10 dB only. The total power consumption of a TC and the display is about 60 watts. This means a 70% decrease in electricity bills compared with normal traditional PCs. Reduced power consumption also decreases the temperature control cost. It also allows us for resource elasticity and sharing. What does this mean? Elastic resource allocation. In Fusion Access, the system implements centralized management and elastic scheduling of resources. It allows us for improved resource usage. Resource sharing helps improve resource utilization. The CPU usage of a cloud data center can reach about 60%, whereas the average CPU usage of traditional PC is 5% to a maximum of 20%. The Huawei Fusion Access desktop solution consists of Fusion Access and Fusion Compute. Fusion Access is the desktop management software that consists of the access control layer, virtualization application layer, virtual desktop management layer, and service operation platform. It provides a graphical user interface portal for administrators of carriers or enterprises to quickly provision, maintain, reclaim virtual desktop. It also implements elastic virtual resource management, improve resource utilization, and reduce costs. Fusion Compute, as we have previously discussed, is the cloud operating system that virtualizes our hardware resources and centrally manages virtual resources, service resources, and user resources. It adapts the virtual computing, virtual storage, and virtual networking technology to virtualize computing, storage, and network resources, and centrally schedules and manages these virtual resources. Fusion Access and Fusion Compute allow users to perform operations on portals that have a graphical user interface, which is easy to use and to understand. So we have two portals. Let me scroll down. Okay, this is how does it work? Sorry, I spoke more than I should have. I should have scrolled down to this slide. This is what I previously spoken about. These are the main components of Fusion Access. So it's Fusion Access and Fusion Compute. And now we have the portal. We have the Fusion Access portal, which helps me configure and provision virtual desktop, and it implements also the routine maintenance of virtual machines. And we have the Fusion Compute portal, which manages the infrastructure, the hosts, the clusters, storage devices, and the network. In this portal, we can also create the user VM templates. It implements some maintenance operations for VMs, such as logging into VMs using VNC, migrating VMs manually, managing disks, and preparing snapshot backup. Okay. So now, how does Fusion Access help me? Well, I think we have already discussed pretty much of it, like the information security, the efficient maintenance and automatic control, the reliable service provisioning, reduced noise and power consumption, the seamless handover, and the resource elasticity and sharing, which is really a great and an easy way to provide virtual desktops. Now, sorry, would you agree it's time to go to the challenging cases, or do you want me to talk a little bit more about?
Let's go to challenging cases.
Okay, then let's go to challenging cases. This one is really interesting. It was one of my projects in Finland. It involves Fusion Cube. This was a very important customer. The customer, they are an infrastructure provider, and they need the virtualization solution to provide cost-effective infrastructure to its own customer. The main challenge was because traditional or the standard solution for Fusion Cube, Fusion Access, or even Fusion Compute, so for each and every virtualization platform, the standard solution is that you deploy it in two separate data centers, okay? Because we have an active and standby side. The challenge was that we deployed it on three separate data centers. This was a first in Huawei designs and also a big change, as this is a non-standard solution. Some were concerned that if we have, I don't know, a network failure or a network error, we might have downtime or we might have a business impact. And it might not be possible, but actually it was possible. We deployed it. You remember, because I spoke about MDC and Zookeeper. We deploy the MCNA, so the management server, in one data center, the second and standby MCNA in a second data center. And each of these servers has its own MDC and Zookeeper components. But we also have a third, because if you remember, I told you that we need to deploy MDC and Zookeeper in 3, 5, or 7 nodes. In this case, we had 3 nodes. So we deployed in the first data center, MDC and Zookeeper. We deployed in the second data center, the MDC and Zookeeper. And we chose a third data center to deploy the MDC and Zookeeper components. This means that in worst case scenario, if 2 of the data centers fail, we will still have the business up and running. It will, of course, be in an emergency mode, but it will be up and running. We will not have any data, data, and not lose any data or any valuable data, because any data is valuable nowadays. And another challenge in this case was partitioning. When we use the Fusion Cube Builder to deploy, we can only select, because if you remember, we spoke about the distributed cluster storage. We create one big storage pool out of all the servers using all the ordered disks. And the customer didn't really want that. They wanted actually to have 2 separate storage pools. Each server, we had a total of 16 servers. Each server had 10 8-terabyte disks, and they wanted to use 5 of those disks in each server for their customers and 5 of the remaining disks for themselves. So where is the challenge in that? Well, the challenge is the tool doesn't allow you to do that when you first install it. So you have to install it, use only one storage, you create only one storage pool, then you have to manually go, delete the storage pool and recreate it into 2 storage pools. This way you can meet the customer expectations, because they wanted to have a nice isolation between the disks. You can, of course, do it from the menu to provision to customers certain LANs, so they have access to only a part of the storage, but they wanted to have a nice, clean, hygienic isolation. So this was a challenge as well. And as some say, challenge accepted, and we managed to meet the customer expectation, deploying it on 3 data centers and splitting the storage pools into 2 storage pools, 1 storage pool, 2 storage pools. So this one was a big success. And I hope, no, in fact, not I hope, I know that the customer was really happy in the end. Now, the next case that I want to present to you is not really difficult, but it involves a lot of planning. And planning, as you know, it can always be really difficult. Why? For example, this customer was really important. I'm not allowed to say, but I will say it has something to do with television. And they were using the Fusion Access, so they were using virtual desktops. They wanted to expand their capacity. More specifically, they wanted to expand the memory capacity of their servers. And another challenge is they want to do that without having any downtime. How can we achieve that? Well, by very careful planning. And this is, if you remember, I spoke about VM live migration. this is where VM live migration comes into place. We migrate. For instance, we had 16 blade servers. We will make the operation on one server at a time. We're going to take, for example, blade 1. We're going to migrate all the VMs from server 1 to another server. Then we power off this server. We plug out or plug in the new memory, power on, make sure everything is okay and that the new memory is recognized. Then we migrate VMs back. Then we proceed to the next plate, and so on and so forth. It's not a very difficult operation, but it requires careful planning and it's time consuming. And since every time there is a very tight schedule, waste time on I don't know, misclicking or wasting time, I don't know, doing other stuff that it's not related to this operation. So this one, although it's not difficult, it requires careful planning, and it also requires VM live migration. And we need to make sure we prepare this operation beforehand. We inspect every server, we see what VMs are running on it, and when the time comes for the operation, we migrate those VM, then we migrate back, and each server at a time. And this operation was also a success, and we can say that we're really proud of it.